On page 3 of your chapter 4 activity, I have games of chance, and I told you to skip that, but I just realized that you do want to know what expected value means. So the expected value of x is the same thing as the mean. Remember how we did x times p of x and then added up the results to get mu? That is the expected value. Now, I won't be doing any applications on gambling or games of chance. I just feel like nobody relates to that. I mean, maybe I'm wrong. Are you guys gambling? I certainly am not. Doing a spinner and then betting money on the result, I just do not relate to this at all. So I didn't want you to have to worry about these homework problems, but if you did do it, you write your x, you write your p of x, you multiply across, and then you add up your results, and you get your expected value of x. So you won't have to worry about that. The two other examples of discrete probability density functions arise in specific situations that you're going to learn to recognize. You will provide the parameters from the correct distribution to your calculator, which will then generate the probabilities for you. So back in this example here, we used the survey results to generate the probability for each value of x. X is a discrete random variable, so it's a random variable that will only take on discrete results, 0 through 10, meaning there are no decimals in there. It's always whole numbers. And so what I'm building up to is that we're going to learn about the binomial distribution and the Poisson distribution. Poisson is a French word that means fish. It's pronounced poisson. I don't know why it's called fish. I'm assuming it was a mathematician's last name. Maybe the guy was French or girl. Anyway, so we're going to learn a little more about these two distributions. The type of story we tell you is going to indicate whether it's a binomial situation or a Poisson situation. So let's check out the binomial distribution. A binomial experiment is going to be when there are n identical trials or n repeated trials. Each trial has only two possible outcomes, hence the word bi. So we call those two outcomes success and failure. The probability of success is going to be named P. The probability of failure will be Q. So Q has to be 1 minus P. So we could have a situation where your probability of success is 30%, then Q would have to be 70%. And the last requirement for binomial experiment is that the trials are independent of each other. So if you do a binomial experiment and then you do it again, the next time around is not influenced by the results of the previous experiment. The random variable x will be the total number of successes in n trials. This will make sense when I give you an example. So let's say you're going to do 10 trials. How many times did you get success? The number of successes is your random variable x. We can create a table listing the possible values of x, which will be 0 through n, and then the probability of each outcome. We're going to say that x is distributed binomially, so we write out the big X, we write a squiggle for the word distributed, and then I say binomially, and then I put the n, the number of trials, and p, the probability of success. These are the two parameters of the situation or of the distribution.